All right. Here we go, guys. Getting kind of caught up, and we'll get going from there. Okay, so we're really digging into some newer stuff and some older stuff possibility here. So, stem plots. Uh, stem has to do with the plant. So, we've got stem and leaves. So, these things that are called stem plots, they have stems and they have leaves. Okay. Now, if you look at page 33 and 34, there's some really, really great examples on them. So I'm going to kind of pull this one together quickly for you guys. So the video's not that long. If you need me to go on it a little bit farther, I will. So, what's the most important thing to do is you have to label what we're dealing with. So I'll explain that here in a second to you guys. So that's the most important thing is labeling. Same thing with our graphs, everything else. So what we can do is this. So if we take the males, and this is, if we look at it, this is the heights of students in centimeters. So if I go the heights of students in centimeters, and then I do this. So I take this here and I go, this is the males. Let's go male. Okay. I go male and I say, okay, I have 154. So I make the stem 15 and I make the leaf 4. And so 154 is done. And then I go 157 for the next one. And then 187. So I got to go 18 and 7. And then this one would be 163. 163. And then this one's 167. So 167. And this one's 159. So 159. So these are the leaves, single digits. And these are the stems. It's just a way to organize your work, is all it is. So now I've got 3 numbers here in a row. 154, 157, 159, and you just keep working your way across as you get going. Okay. So then that's one way. So this is just a basic, this is a basic stem and leaf or stem plot is what they're called. But then we also have ones that are like they say here, back to back ones. Okay. So back to back ones would be for data like this. So I'm going to do this. Sorry about my horrible lines. We go like this, and then I'm going to go male, and then I'm going to go female. And it's so we can compare the distribution. So I know that this one's 15, right? Let's see, 15, 15. Yeah, so 15. And I know for males, I'll do these 3 that I have here, and I'll do the males in the blue. So we got a 154, a 157, and a 159, right? But for the females, I have a 152. Let me do theirs in purple. So I've got a 152, and I've got a 153, and I got another 153. So you got to write it twice. And then I got a, let's go find more. 157, a 157, and then I have a 158 and a 158. Okay, so and a 159. There we go. So now what can happen is you can compare that there are more females right now in the 150 centimeter category compared to the males in the 150 centimeter category. So stem plots are just a way to organize your data. This one is back to back because I have the male on one side and the females on the other side. Okay. Now you can do things like this. This is called a split. And I think I have it next, but I'm going to tackle it now. So let me write 16 in here. So I write 16 and we'll tackle. So we know the males are 163. Let's do a 162. 162. And let's call that good. And then I'm going to do this. I want another 16. And I'm going to do the ones that are 5 or greater. So I'll do those in green. So 165. 165 and 169. So what I did is I split the 160s into 2 different rows. So then I go to the females here, and then they got a lot at 160. So now I won't have this huge line. So I got 160, 161, 63, 63. Is there a 64? No 64. Oh, there's another 60. I forgot a 60, so I just write it on the end. Okay, and then now, there's a 4 right there. You can kind of, that's why I cross them out, guys. It makes it easier. That way you know if you miss something. So then we can go to the next set, which is a 5, a 5 for those 2 165s. And then we've got 2 166s. And then we got a 168. Oh, I missed a 158. Sorry about that. I got a 67. And what did I say? 67 into 169s. So we can split them so they're not such huge amounts of leaves on one. We can do back to back, or we can just organize it singly. Now, what I mean by label, include a scale and a key. So what you do is you go like this, and you take an example of 15/4 equals, yeah, that's going to be too big because my writing is horrid. Equals, what does it equal? It equals 154 centimeters. So that means this. That means anytime I see this, I know that 15/4 is 154 centimeters, 157 centimeters, 159 centimeters, 163 centimeters, 167 centimeters. So we can split things, we can do whatever, but the key, you got to have a label, a key and a label. Okay? So keys and labels are very, very important. All right. We talked about split stems. The split stems are what I talked about right here when I did the 160s. That's a split stem. We take the stem and we split it. So we go 0 to 5 and then from 5 to 9. All right. So a lot of this stuff we may do in class on Thursday just because I want to make sure, especially with the histograms, because it's calculator driven. Okay. So here's the deal. I'm going to quickly make a dot plot of this stuff. Let me shrink it just a little bit here. There we go. Okay, so it asks you to make a dot plot. Well, when we have this many numbers, it sucks to do a dot plot. So I'll just make it. I'll do 100 here. I'll do 95 here. And then I'll do 105 here. So what happens is we start getting lots of numbers. So I got a 9, 98. I got a 96.5. I got a 96.9. I got a 93.4, a 93.2, a 96.5, 101.1, 100.6, a 94.9, a 101. I wish I had the cool videos where I could speed this up really, really fast. And it just as you're going here, we are just bouncing around through this piece here, and we are getting stuff all set up right here. And we got it here. I got people at the door. So I'm doing a video. Give me a second. So we've got it here. So hi, Vanessa. Hi, Ethan. You guys are on video now. So there we go. And so what happens is we get a bunch of dots like this. And once we get these dots, we can't tell the shape. So what we do is we build what's called a histogram. And these are calculator driven. So what we do with histograms is, let's say I wanted the biggest number is around 106, right? So what we do is we go 106, let's just say 106.5, and the lowest number is 93.5. So I take the max and the min, and I get an answer. So that's 13. That's 13. And then I divide it by how many class widths I want, which is going to be normally 5 to 8, but it's really easy to do 5 most of the time. So we're going to do 5. So if I do 13.5, 13 divided by 5, I get a class width of 2.6, I believe. So what I do from there is I go from 93.5 and I add 2.6 to it. And so a 2, that's 95 plus, so this will be 96.1. So then what I do is between those two boundaries, I count the dots. So for this particular one, I go, oh, there's 1, 2, 3, 4, 5. And let's just say that one. 6. There's 6 dots. So what I do is I create the same exact idea, except I go from 93.5 to 96.1, I should say. Let me go back, Control Z. 96.1. I have a count axis over here. So this will be 2, let's just go. This is 5, count of 5. This is a count of 10. So between these two, I have 6 dots on my dot plot between here. And then I add 2.6 again. I know this is getting convoluted, guys, so let me erase a couple of things here. Oops. All right. So then I add 2.5 again. So if I add, or 2.6, if I add 2.6, I get approximately 98.7. So now I go back to my dot plot and I count 98 to 98.7. So I'm going to count 1, 2, 3, 4, 5. Let's say there's 5 of them. So then I'm going to do 5, and there's 5 of them in between there. So what happens is when you're dealing with histograms, you've got to come up with the class width. So don't forget the class width is maximum minus minimum divided by the number of classes, which is usually 5 to 8 classes. All right. So now here's the deal. Calculator does it all for you. You don't have to do all this math and all these different things. So the basic idea of a histogram is that it really is a bar chart, but it's a continuous bar chart. Okay. So that's where we get to here. So bar charts, if you guys notice, a bar chart has a spot in between each. And that's a bar chart. And a histogram will create a continuous looking graph like this. So this is a histogram. And this is a bar chart. That's a bar chart. Okay. So that's the difference between the two. So in class, we'll talk about a relative frequency histogram. So let's just assume I had a real quick histogram of that's something that looked like this. Yeah, it sucks. And then I had 3 to 5 to 13 and 20. So I had these number counts in between there. Well, these numbers don't mean much, but if I changed it into percentages, all of a sudden we have a different setup. So this is 5, 10, 25. This is 45. So we could do percentages of that. And so all of a sudden now 3 divided by 45 is a super small percentage. So this would be 3. It's right around 8%, let's say, because I did 3 divided by the total. And then all of a sudden 2 is even lower. It's like 5%. And so again, we're at a point, this is percent, where a relative frequency histogram bases it on 100%, and it allows us to visually, and we have the ability to see it a little bit better because it's based in percents. Again, we're going to do some of these in class, which will make it easier, and we're going to generate them with the calculator. How are you going to do it? Don't do labels, okay? And then don't mess up your x-axis. And we're going to talk about that. It's a very common mistake using Excel, but not us really. Okay, so that's the basic idea. Again, be ready on Friday, on Thursday for calculator work examples. We're gonna hammer the calculator examples right after the opener. So we're gonna be ready to go. We may actually do it tomorrow on Wednesday. So there's your video. Good luck, and we'll see you soon.